So today we have Arnaldo Carvalho de Melo, a senior principal engineer who is the lead maintainer of Linux Perf, a very popular tool for performance profiling, tracing, and debugging. He also implemented the Linux DCCP stack and refactored the TCP/IP stack. Arnaldo created pahole, a tool to help in optimizing data structures used in Linux, glibc, and other code bases. And lately, Arnaldo got lost in the BPF land. Arnaldo, welcome and thanks for coming.
And thanks for having me. I'm Brazilian. I work from Brazil. I work for Red Hat since 2007, and before that, I worked at a company that I created, Connectiva, in the early days of Linux, from 1995 to 2007, something like that. And I work nowadays in the last 10 years or so, in the Linux Perf tooling. I did kernel coding for Perf, and as I did kernel coding for the network stacks and etc. But nowadays, mostly I process patches not for the kernel, but for the tooling side. So many people who are actually writing code these days are people from all over industry, from universities, from Facebook, from Google, from Intel, from AMD, from everywhere. So it's a big community, and I'm really proud of being part of it and facilitate the improvement of these tools.
Cool, and I think we're glad to have you as well. Like, you are such a recognized person in the Linux community, so that's really great that you found time to join, especially on Sunday. Yeah. So Arnaldo, let me first ask that is this maintaining Linux Perf? Is it your primarily responsibility at Red Hat? Like what is your relationship between you, Red Hat, and Linux Perf?
Yeah, so Red Hat, I joined Red Hat back in 2007. There were two possibilities for me to join Red Hat at the time. Tim Burke was my first manager. After that, he became vice president, and I think that he's by now retired. So he said, "Oh, you can join us to work with virtualization. We have a big team, something like 25, 30 people. Or you can go to this new team that is trying to get the real-time patches merged upstream, and we want to have a product that is based around a deterministic kernel." And so I looked at who was working on both teams, and I had friends on both teams, but the smaller team, and for me, the most interesting one at the time was the real-time one, because there was Ingo Molnar, who the guy who needs no introduction, and Peter Zijlstra, and then Steven Rosted, and Toshner. So were all my heroes, and I knew all of them, and I respected them a lot. So there was a lot to be done in that area, and most important, there was a lot to be done in writing tools to reduce complexity, to try to understand why something was not behaving the way we wanted, why there were latencies, we wanted to know details about how the system worked, to find the reasons why determinism was not being achieved. But my relationship with Red Hat is being part of this team, and I'm part of this team to this day. As time passed, maintaining Perf and occasionally working on pahole took most of my time. It's a black hole. It's lots of things and a growing community. And the Red Hat understood that it was better to leave me alone. To leave me work on this because it's such a set of tools that are used by everybody. Everybody uses Perf. It's not because I'm working on it, because most of the Perf tools I was just a facilitator. Lots of things, lots of interesting ideas came from interactions with people like Linus Torvalds and Thomas Gleich and Peter Dutra, and a big number of other people who came and say, "Oh, it would be cool if annotation would simplify the output from being utils. It would be interesting if we could jump from one function and to another, navigate while looking at the samples that for each of the lines." Linus Torvalds sometimes say, "Oh, I don't care about the source code. I want to see just the assembly output." So from this kind of interaction, the perf became something that was done by a community, and I think that's the main reason why I'm still working on it, and people have been contributing.
Okay, yeah. Let's actually dive, straight into the Linux Perf. So, and Linux Perf is just the tip of the iceberg, right? And I think what's more important is Perf events, right? So right. Can you please explain the difference between the two, and how big is the code base of like Perf events in comparison with the code base of the Perf itself?
Yeah, I'll take a look at this, because the thing is, before Perf, there was this difference of what should be done by the kernel and what should be done by user space. So OProfile was the profile that was available before, and probably the reason for Perf to come into being. In the OProfile philosophy, the details should be sorted out by user space. And the guy with Perf event open, the syscall and how it should be working, they had a different idea. So they thought that the kernel should abstract away details for profiling. I mean, for the main ones, for the main cycle, CPU cycle, cache misses, the basic ones, which make up most of the experience of most people. So they try to map cycles to something specific to microarchitectures in Intel, or which there are many, and for microarchitectures in AMD and PowerPC and all the other ones. While OProfile just exported the events as they appeared on the vendor documentation. So that was one of the main things. The other thing was that OProfile used let's say a daemon, and then you had to start the daemon, and then afterwards you would just communicate with this daemon asking for information. And Perf started without a daemon. Nowadays we have a daemon for long running sessions, but this is not the thing I was talking at the start of Perf. So and then the other thing was that Perf is not restricted to profiling. Even having this name, Perf, which is a bad name, just too short and too generic. Perf, the infrastructure for Perf, it's one that allows you to go from profiling to basically just counting, sampling to counting, and to get debugging the mix, tracing, like all sorts of tracing, like the static trace points or breakpoints that you add at our basis. And then you combine counting with debugging. Let's say you insert a probe at an arbitrary place in user space or kernel space, and then it's a new event. It's just one of the events that Perf can read, not just in addition to the ones that you get from the processor, from the performance monitoring unit on the on the performance on the CPU itself, in addition to counters or sampling that you can get from the operating system. So it's not just about profiling. You can combine all those things together in interesting ways. So I think that this is, gives a good initial vision of how Perf works and how it's different from previous attempts at a tool like this, or an observability tool like this.
Mm-hmm. Okay, so since you already started talking about this op profile and other tools, so how do you think how widely is Linux Perf adopted across the Linux ecosystem? Do everybody in the Linux world strictly use Perf and all the tools that are built on top of Perf events?
Take a look. When I started working with open source, the way you had to figure out if people were using what you do would be to not on purpose, but break something. When something breaks, then people start complaining, and then you realize how many people are using that thing. So, but there are some things that tell me that lots of people use it. For instance, in the past, Intel vTune, the profiler, the graphical profiler from Intel that's available for Linux and is available for all the platforms that Intel supports, Linux or whatever. Nowadays, it's in Linux. There are two modes of operation. One came first, which was Intel had this kernel driver to expose the performance monitoring unit of processors so that the graphical interface, the user space part, could get the information it wanted, could program the hardware like via this kernel driver, and then get the information, process it, and show it, and then myriad many ways that they went on building over the years. But nowadays, one extra mode of operation, which I think it's the way that they want to have it in the future, currently and in the future, is to simply create a big perf record command line specifying what they want. Oh, those are the events I want. This is the sampling frequency. This is how I want to program each of the events I want with backtraces. This other one I don't want. This one I want with backtraces, but just 5 levels deep, or this other one with different frequency, and so on and so forth. And so vTune is basically now a front end for Perf. So this brings out of the blue lots of new users that will not even know that they are using Perf. So I think that's an anecdote that could help understanding if Perf is being used widely. Yeah.
That's actually interesting since you started talking about vTune, right? Well, I certainly while working at Intel, I still don't know the long-term strategy for vTune. I can obviously speak for that, but Intel vTune long time has this integration with Perf. It can import Perf results, the data that was collected with Linux Perf, right? Okay, but let me also ask. So there are also tools like, for example, I remember gprof, I used it a long time ago. So on the Linux, is Perf the de facto standard way of profiling?
I would say so, because gprof requires you rebuild your. That's another thing which is interesting to mention about Perf. Perf doesn't require you to change your binary. It doesn't require to change what's being observed. Yeah, you don't have to, let's say, reboot your machine with special kernel so that you can collect information. It's available everywhere, the kernel part and the user space part as well. It doesn't require what's being observed, neither the kernel nor the user space workload that you are profiling or observing in general to be changed. So it tries to reduce as much as possible the impact of observing. I mean, he went counting, which is easier. You're just counting things. You program the CPU PM. It will not interrupt anything. You're just counting things, and then you get from time to time well, at the end you read some counters that are maintained by the CPU, or sampling, where you have all sorts of ways for specifying how often you want to get the sampling, or what should come with each of the samples, like backtraces or the values on CPU registers or a chunk of the stack or whatever. So yeah, I mean, I think I would say that perf, at least the perf record part, it's the standard. I mean, there are like VTune can use perfs and behind the scenes, and then it will show you will not be using perf report or perf script. You will just be using perf record. But and then there is hotspot from Million Wolf that works at KDE and Qt. So he has this graphical interface that it's kind of like an alternative to VTune, and then it will provide flame graphs. Or even Brendan Gregg, the first flame graph software in Linux was using perf behind the scenes, and so yeah, I would say that perf it's used widely.
Mm-hmm. Yeah, I mean, sounds very, very reasonable. So, okay, so Arnaldo, you are the the maintainer of this the most popular performance profiler on Linux. So how are you using Linux Perf, and like what is your approach to performance analysis?
So in the past it was fun because most of my time it's involves processing patches by now. And so as I mentioned on a previous conversation with you, is sometimes I'm not using perf. Let's say I'm just processing patches, running, looking and reviewing patches to see it makes sense and etc. And then coming up with performance tests. There is a subcommand for perf. It's called perf test. And perf test will run perf. We will stress test, let's say, functions in its libraries. It will as well run command lines and then intercall to the kernel and look at the perf event attribute, which is one of the arguments for the syscall, for the perf syscall, and see if what's expected is there. And so, because this is really complex. I mean, both the tool and the kernel part of perf, it's complex. I mean, it's a lot of options. I mean, I think that the most complex system call for Linux is the perf syscall. It's a struct argument, and there are many ways that you can program it. You can. I mean, it's a lot of stuff. So making sure that it continues to work, and that when you are trying to understand your workload using perf, what it's providing back to you, it's valid information and not just a distraction. It's way more important than profiling perf, which is something that I did and continue to do from time to time. So the main workload that I use to profile perf is perf. To use perf to profile, it's perf. You use perf to profile perf, both when you are trying to figure out why it became slower, or when something doesn't work, and then you have to trace the kernel part. You have to trace the user space part. Yeah, so that's my use case. But for most people, the best starting point, I would say, it's Brendan Gregg's perf webpage. He has a long page that starts with one-liners, like very simple stuff that you can do. Something you want to know how many context switches are taking place on some specific CPU or some specific program, or you want to know how many times a specific function has been called in your workload. And I mean, he has a lot of those one-liners. His books have chapters on Perf, and then he connects the use a method that he has developed with Perf. So he said, oh, you should start measuring contention for resources and things like that. He has a technique that he describes in his books, system performance, but if I would say quickly here, it would be first to start looking at Perf top. Perf top, that's, I mean, just like top, you start Perf top, and then you see snapshots of what's happening on your system. And then from Perf top, you can, let's say, press enter on the function that you are suspicious that is related to the problem that you are experiencing. And then it switches to a Perf annotate view where you're going to see the source code involved in C or just in assembly. And then you're going to see, I mean, you're going to have an idea of what's happening, just like you do with top. If you have some specific, when you are trying to optimize your program, you start with something and say, no, I don't want it. So I start by running perf stat, like statistics, perf stat, and then the name of the workload. It runs, it finishes, you get a bunch of numbers, you get default counters, like for CPU cycles, cache misses, cache hits, and then you can run it, let's say, 5 times, so that you get, I mean, averages. And I mean, running just once may not be representative, so you have to run it multiple times and then do the calculations to get some average for multiple runs. And then you save that information, and then you do your changes. You can do your changes on your program, on your workload, and then do some optimization. You try, or you don't change the program, but the source code, but you change the compiler, or you change some library. You change some component, be it the source code by you changing the algorithm, or using a new version of a library or a new version of the compiler, or you are trying on a different machine. So, or all those things at once. I mean, it depends on each use case. And then you run it perf stat again. And then you look at the numbers again and you say, oh, yeah, it got better. Now it runs faster, and I can have an educated guess that it's running faster because I'm having less cache misses here. So I reduced the size of some data structure, let's say, or I reorganized the data structure so that I get benefit with reference, or I'm avoiding things like false sharing, and then I get the better performance, and I can have an educated guess of why it was like that. Or you can as well say, no, okay, I want to see if that specific function is involved. I mean, that function is I see that function is appearing on the top of my profiling, but I want to know, and then I can use perf probe, another subcommand. It's a perf probe dash capital L, and then the name of the function, let's say, and then you see the source code for that function, and then it will tell you where you probes, like K probes, or at the beginning of the use something better if available, like the ftrace infrastructure to reduce the cost of the probe. And I will say, okay, I understand that this is the function that is taking the most time, but now I want to run again, and I want to know what's the value that this variable here is taking. Because if I understand for this variable, then I can make another educated guess and change some stuff and say, no, this is happening because memory consumption is high, or because I need a better hashing algorithm because the distribution is not good, and so I have to change the algorithm, and then I run it again, and then I look at it, and so it improved it. So the extra information I got from adding probes to this specific place here in this function helped me to figure out the problem.
All right. Yeah. Cool. I think that, yeah. So actually, so when you talked about perf stats, so yeah, I just remembered that for a while I actually had an alias for that which I used to run absolutely every benchmark. Like perf stat is like almost zero overhead, right? And it can give some interesting statistics about the program execution. You can sometimes like see the anomalies like really quickly.
Yeah.
But yeah. Okay, let's now actually open it for feedback, right? So as you asked for, Arnaldo. So folks from the audience, if if you have any kind of feedback for Linux Perf, like tell us like how do you use Linux Perf and how do you think it can be improved? Like if you have any thoughts, just again request the mic. You can also post your comments in Discord chat. So one other thing that I want to talk about is that well, let's talk about all the things that maybe can be like not necessarily can be improved, but let's say potential feature requests for Linux Perf. Okay.
Right.
So well, first of all, Linux Perf is like frequently blamed for, and okay, sorry for stating the obvious, but like Linux Perf is frequently blamed for having limited graphical interface, right? Well, many tools are built on top of Perf, and like you mentioned, hotspots from KDAB, right? And I think that still Linux Perf still has its own place, right? So nothing can replace the usage model when you log into a remote machine through SSH, right? You and like you don't have like those tools like vtune and hotspots, like, but Linux Perf is like you can almost sure that it's there, right? And you don't need to install anything. You just run the Linux Perf and that's it, right? And then again, if you want to if you want to run vtune, then you also have to first collect the results, then you have to copy the results back to your machine, open it, and then the versions are not matching, and then so on and so forth. So I mean, still Linux Perf definitely has its own place. I no doubt about it, but let's see. So do you have any comments like on the graphical interface of Linux Perf?
Yeah, but the thing is, in the past, in another life, I did some graphical programming, but I'm these days I'm not the person to be driving these working on it. In the beginning, there was an attempt of having histogram code. I mean, the histogram code that is used on perf.top perf report, use it from a GTK interface. So there was an attempt at the beginning of having the perf report interface graphically, but that byte rotted. So there is not nobody working on it. So it's like a dead end. Then there was another thing which was another attempt was perf time chart. I think it's time chart that Ian Devane, the guy behind PowerTop, contributed. But I mean, yeah, you can get some SVGs out of it, and then look at some of the like trace events over time, and then get some information. And then more recently, a co-worker at Red Hat came up with perf flame graph. So that helps a bit in collecting the information that is needed to create a flame graph, and then creates an SVG out of it, and then you can look at it. So, but yes, I think that if we could come up with some really simple graphical interface that could ship together with Perf and be readily available everywhere, that would be a good thing. It's just that getting a good graphical interface, it's not something that's really easy to do. And so far, the attempts that were made at having a graphical interface were from outside tools, the tools that use Perf to collect the information and then process it, but they are not shipped together with Perf. So yeah, I think that if somebody would be interested in working on this and contributing it, but it's not something easy to do. It's something that even with with hotspot being something that for a group of people, for a set of use cases, it's good enough, and for all the people who are using per VTune, so it becomes even, the less motivation for people to. You mentioned that sometimes the versions that are, you collect the data, get the perf data, transfer to another machine, and then on the other machine you don't have the binaries, or you don't have the matching binaries so that you could do simple resolution or annotation, etc. This in the beginning we had perf archive that it's a subcommand, then you run it on the machine where you collected the data. So the samples, then it would look at the perf data, find the binaries that were referenced, that had samples on, and then would create a tarball, and then you would transfer not just the perf data file, but this tarball, which would contain the files required for you to do the simple resolution. Another thing was there was another guy who did it, a SimVer, SimFS, which is if you have, let's say, a embedded system and you get this image of this embedded system, for the developers that matches what is on the device, then you can point to some CH root and it would get the right information from there. And more recently, Perf has support for the debugging server, where you get just the perf data, and when you are doing analysis, it will query a HTTP interface saying, "Oh, I want this build ID," and then I don't want the whole debugging file. I want just for this specific file. So it gets this from the debugging server, and then you do simple resolution, which is deterministic, because the build ID that is collected on the perf data file for that specific DSO will be obtained from a server, and then you can do simple resolution. Yeah. Ask you that?
Oh, sorry about that. I was talking on mute.
Yeah.
Sorry about that. Yeah. So, okay. We actually have one request. Okay. So let's approve. Andrew, hi.
Hi, I had a question or comment. I really like Perf. One thing I noticed was that kind of including kind of Perf and other kinds of events, like let's say like scheduling events, or if you're having like processing queries, like query start, query end events. I feel like you can always use like perf script and analyze it by hand, but then you lose kind of like all of like the niceness of perf report. Is this just like a UI thing that no one's kind of thought about, or what have you done in the past?
Yeah, perf script started as a way for you to just dump, let's say, the all the evidence, and then providing the information. I mean, the decoding. If the sample had collected the values for registers, then it showed the name of the register, the value, etc. If we would see all the back traces for each of the samples without doing the aggregation that the report does. After that, it became something for you to generate Perl or Python, a skeleton. Then you would get all this information, and then look. You could then do the aggregation yourself. You could go there and in Python create some tables, and then when you get to start some transaction, let's say, you would record the time or the values for the arguments for the function entry, and then at the end you would measure how long it took for that specific transaction that starts with a function and ends with another function. And it's something that was not easily scriptable through the Perf report one. Okay, so there are a good number of scripts that are canned that comes with Perf, so you can look at the reasons for a UDP packet to have been dropped, and if it's the application that's taking too long to respond, so the buffer fills up and then something it gets dropped, etc. What you are asking is something like exporting to Perf script aggregation that Perf report does, and that's what I understood. So it's not possible, but as you say, it's a matter of providing the way. I think it's actually a good idea. I mean, you get more of the functions that Perf report uses, like for resolving back traces or doing symbol resolution. But there are lots of things that it's done automation, and then you could in Perf script say, oh, this sample, I don't want this sample because of some characteristics, and then discard it. These are the one I want. So add it to the aggregation that Perf report does. Let's say be creating a filter, let's say, or you could get what you get from Perf report, but you could get some extra summary that is based on a set of rules that you come up to aggregate that data. So yeah, it's not available, but it's a good idea. It's something export more of what Perf report does to be accessible from Perf script. Yeah, it's interesting.
Thanks.
So I actually also have like the second feature request, and this is like related to. And this is actually none of the existing tools can do that right now. So like like the idea that I have like in mind for a long time and wish and like what I wish to see in the future is that like visualizing the hyperblocks or also people call it sometimes super blocks. So the super block is just a chain of basic blocks that represent the hot path through the function, right? Okay, so maybe let's go back a little bit. So okay, so for those people who don't know what is the basic block is the sequence of assembly instructions which has one single entry and single exit, so nothing can jump in between this basic block, the sequence of instruction. Why we need this abstraction? This is like really useful for compiler developers. Like it's essentially like you can view a basic block as a simple single instruction. You can simplify a lot of analysis this way. All right. So I mean, I think critical path in the through the function is like usually like something that you want to know, and which will give you a better understanding of what's going on in this function, right? So you only care about like what is really the hot path through my function, and this is essentially the chain of basic blocks, right? The sequence of basic blocks. So do you think that's might be possible? I mean, I understand that might require a graphical interface again to expose this better, but well, maybe someday we will see it.
Yeah, I mean, Perf has some support to basic blocks. Peter Zutra added some support some long time ago, and I had to he has a request for me to get this improved in the annotate interface so that you could see that part there is a basic block, and then the number of cycles that are happening, not just in some specific line in the basic block. So this basic block is taking that many cycles or whatever, or any other metric that you are interested. And then the interface that you are asking could be even, let's say, use something like GraphVis, and then you export a GraphVis, a dot file, and then you're gonna see the relationships for the basic blocks, and then some sort of this representation for this super blocks that you are mentioning. So yeah, I mean, improving the support for basic blocks, and on top of it, improving the support for now a meta concept like this super block. It's also a good idea. It's something that I think that some motivated person could try to delve into the annotate code, see what is the basic block support that we have already, and then try to produce some proof of concept generating some dot file, and then trying to use GraphVis to visualize it.
Mm-hmm. Yeah. So we actually have like an internal tool that's capable of doing that using the Intel LBR.
Yeah.
Yeah. So I don't know if the similar approach can be done on other platforms, but I think you can also reconstruct the basic blocks from the debug info. No.
Yeah. I'd say so.
Or maybe you need some additional analysis, like But anyway, okay. All right. Let's see. I will approve Luis first, since he was first to request the mic. Luis, hi.
Hello. Do you hear me?
Yeah.
So I have a question about like perf and kernels. I'm building like kernel, and I've been thinking about building. I want like performance statistics. While the kernel is running in like a virtual machine, KVM, for example. What would be the approach to do this the most simple way?
Yeah, I mean, you have to. I mean, you are asking about how to correlate what happens inside a virtual machine and what happens outside the virtual machine. Is that true?
Yes.
So, Marcelo Tosati, which is a co-worker at Red Hat and a longtime friend of maintaining the Linux kernel back in the 2.4 days, he has been pushing for a patches to be accepted in the mainline kernel. Try to help in correlating the clock for what's happening inside the virtual machine and outside the virtual machine, so that you can connect both. So the idea would be for you to communicate with a perf component that's running inside the virtual machine. It would collect information that you want, and then you collect information outside of the virtual machine on the host, and then afterwards you would merge both files. And then you would have a unified vision of what's happening inside one guest, the other guest, or maybe multiple guests. Perf as well has support for exporting data to that CTF format, a common trace format, which is a format that was put together by the LTTNG guys. And so which is something that goes back to that graphical interface question that we had in this call. So you can use the graphical interface for LTTNG, trace compass, and then get the information for perf, convert it to CTF. And then I think that they have ways for you to merge multiple CTF files, and then you would connect both and then use trace compass to have a graphical view of what happens inside the guest and in the host in a single view. So I think that would be one of the ways for you to try to go correlate
But
what happens.
yeah, but I'm like I want to avoid to make a compatibility layer for perf inside the kernel. It's what I envision is that I can just like run perf outside
Yeah.
on the list and then like get statistics from the guest basically. I tried running perf KVM.
Yeah.
But I didn't like I like my kernel symbols like I piped in them to NC and then tried to like feed them in a perf KVM, but that didn't work at all. Um, I think like correct me if I'm wrong. I see two options like somehow getting these symbols to work with perf KVM or like creating like memory page where there is like the struct like perf reads the stuff from the kernel, making it compatible with perf and then like trying to get this information out. And I don't know what would you think would be the right approach?
Yeah, I think that Perf KVM should be working. If it's not working, it's because it's not finding the right files available. I mean, so we would have to try it. What I would recommend for it would be for you to describe the steps that you went through, and and submit it to the mailing list, and as the first step. So because then there are several details that we're gonna miss in having this conversation right now. Let's say I don't know specifically what version of Perf you are using, how you are collecting the symbols from the guest, and maybe there is one misstep here or there that is getting in the way of you get it. So in the end, it could be that the existing tools could be enough. It's not producing expect because there is one little thing that is missing, and there are many things that can go wrong in this case.
Okay.
Because you're gonna have two different kernels, one running on the gas, the other one on the host, and then it's a lot of moving parts. We have to write this down so that we could go point by point trying to figure out what may be wrong.
Okay, I will do that. Thank you.
Okay.
Hi, Mark.
Yes, I was just curious. How often do you guys, in your performance tracking duties, do you use the snapshot mode of perf with Intel processor trace to track performance anomalies?
Yeah, as I say, I use it. What I use from Intel Performance Trace is mostly to test the patches that I get from Adrian, and it's a world into itself. I mean, the Intel Performance, what you can get from Intel Performance Processor Trace, first and foremost, is a lot of information. It's lots of information. So you have to somehow reduce this amount of information, like trying to use filters and to reduce this. But what you can do with it, it's really impressive. I mean, but I'm not using it on a daily basis or even frequently. But not because it's the support is bad or because it's not something that you shouldn't be using, but just because I don't have that much time to use it. I would love to have more time to get into the processor trace. There were ideas about, for instance, for tracing what happens inside short-lived functions, which is nowadays it's BPF. Yes, you have this bytecode that you insert in the kernel, and it runs. It should run real quickly, and then there are all sorts of artifacts that can happen from using it. So ideas about how to enable processor trace just when you get into BPF, eBPF program, and then disable it immediately when you get out, so that you can get the precise trace for eBPF is something that I've been considering doing, and that could bring me closer to connecting BPF and Intel processor trace, or even core site. Yes, that there is the equivalent to some degree in the ARM world, like the core site, which is kind of like processor trace.
Thank you.
Okay.
Yeah, I would agree actually with Arnaldo. Yeah, so I would say that I have never used processor traces in my real daily work. Like I certainly with it. Sorry about that. Someone was calling me. Yeah, so for most of my daily work, processor traces is just an overkill, right? Yeah, so it's great for tracking performance anomalies. As Arnaldo mentioned, like it can become even better with this BPF support, and that's great. Yeah.
I've only played with it, but only in the context of using Intel VTune, because they make it pretty easy to use. But I haven't played with it via Perf yet, so that's why I was curious about if the Linux kernel community has actually used it.
Yeah, I mean, the thing is, I can't talk for the current community. Let's say that there are lots of people who use those tools, and then they find what they were looking for, and then they are satisfied. And so most of the time, when you hear about somebody using, when I hear from somebody using Perf, it's from the comments. I mean, on mailing lists, on the Linux kernel mailing list, where people say, "Oh, I was running, and then I got this and whatever." So I see the output from the tooling, and then I can even look. I use MUT, the mail user interface, and then I can see, oh yeah, people are using it, because you see, he got the numbers for this, and then he say that the new algorithm is better because he's getting less cache misses, and then it's using Perf or even pahole to look at the structure. So I see it, and that's one way for me to list to see. And the other thing is when something breaks. Yes, when somebody say, "Oh, this is not working," I say, "Whoa, people are using this feature." I mean, I didn't know about it. I mean, people are using on yesterday. I think that after Danny sent the email saying, "Oh, Arnaldo is interested in hearing from the people using Perf, what they have from suggestions or things like that, or problems that they are experiencing." Travis down, which was here. I don't know. Yeah, I think that I don't know. I think he left, or he was, but he was here, and he said something like, "Oh, I have this problem with annotation when I'm looking at the C++ function, and then there are jumps, and in the annotation interface in Perf, you can look at this assembly and see that what line is generating cache misses, or any of the other metrics. And then if it is a call instruction, you can press enter, and it will navigate to that other function, and then you're going to have the same interface showing where things are happening and things like that. And if you have a jump, and then it will have this arrow pointing to the direction of the target of this jump, this if instruction. And if it's to a loop, let's say, it has an arrow pointing up. And but that was a problem that he detected in 2019, like about 2 years ago, and he reported. And when then he said, "Oh, I'm interested in information about what problem," he sent it to me. I tried it, and it seems to work for me. So I'm now waiting for him. But that's when you listen from, or you get information from users, from how people are using.
I'm still here. It seems to work. I just tried it like 2 minutes ago, and I checked it many times over the last years, and it never worked, but it must have been fixed sometime. I just synced to this tip, and it works. So sorry for that noise.
Oh. No. It was really interesting. I mean, to show, to provide this kind of discussion here. Perf is as good as its users, I would say, because the information it provides has to be validated, and the one person that is the subject matter expert on that specific workload or compiler or whatever. So I don't get that complaints from people like you. I'm doing it well.
Now that I'm talking, maybe, Arnaldo, I'll ask you one thing, because Dennis had asked for feedback on how people are using it. One thing that I'm looking for, and I'm curious if you guys have thought, is like, I like to use the Perf event subsystem, so the API that Perf is built on, within my program to like time, let's say, a small interval of code, or to turn on and off events programmatically. And one thing I run into a lot is like, Perf itself, the tool, knows a lot about the events that are available. So I think you guys have the JSON file that you compile into the binary. But I don't think there's any way for programs to access that. So like, I always have people be like, oh, I want to use this event. Perf list shows it as available, but I have to use like another third-party library to parse the event, hope that it's the same as perf, and then all the thing about the event string. Do you guys have any plans of making like a libperf or something that might be?
Yeah, I mean, actually, we have libperf. In the kernel sources, you have tools/perf. That's where perf is, and then the libraries were up to something. Let's say all into a util subdirectory. So you had tools/perf/util, and then the things were there. But then lots of people asked for libperf just like it did, and so we created tools/lib/perf, and then there we have parts of we don't have everything. We started moving simple things, and then there are regression tests that is specific to libperf. And more recently, we are starting getting patch submissions and for exposing further libraries that we have in Perf, but we haven't moved it yet to libperf. And quests, like I want to have a group of events, not just one event or two events, but I want to group them. And for that, you have some specific magic that you have to do to set up the request to the kernel, these event, and then the first one is the leader, or you want to have the first event when it happens, then you just read the counters for the other one. So that there are lots of things that you can program the kernel perf subsystem, and that those are being exposed to libperf as people request it. So any use case that you have that I know that I can do this with perf, but I would love to do this with libperf, and that I could link it with my application, just like you described it. So I think that now is the time for you to do that. Giosha, a Czech guy, who helps me, and that, I mean, he's a co-maintainer for perf for the tooling side, and does a lot of work in the kernel side. He is the main guy behind libperf, and I think that exposing the parsing of events is something that he is working or was wanting to work or something like that, so that you could use event names, and even the ones that are in JSON from the from the vendors via libperf. So I think that this is something that is happening, and so you should be able to using libperf, linking with it, get access to the events in the JSON files.
That's awesome. Thanks for your answer. I guess just one follow-up question. So libperf, I assume GPL too, right? So you could use that if your software was
Yes,
built
yes.
GPL too, right? Okay.
Yeah,
that works
because
for most of my use
Perf,
cases.
yeah, go ahead.
Sorry.
No, go ahead.
I was just saying that works for most of my use cases, but I know sometimes I couldn't use that, so I could like still try to parse the perf list output. Or I know Andy Clean has his JEvents library, and there he's re-implementing again the event string parsing like that. So I guess for some people, there's all the GPL stuff.
But one thing you could do that would help you, I mean, Perf has this variables mode. So you can say perf record or perf stat or whatever, dash v, and then if you go on adding v's, you get lots of extra information. And one of the informations is how the perf event attribute is set up. So you could say you could. I mean, we could make it easier. Something like, oh, you do perf stat dash dry run, let's say, or just show me how you set up things, and then it would provide you with a compilable perf event attribute that you could then include into your program. I mean, it would run somewhere. It would provide you with just a snippet of, I mean, the declaration of the attribute, and that if that is enough, then you would get part of what you get from the parsing without licensing issues, because you would not be linking against it. You would just using it to ask how to set up the event. But I don't know if this is enough.
Yeah, thanks, Arnaldo. I was doing something similar, although I didn't put enough V's on the command line to see that. I really appreciate your answer.
Okay.
Yo, Dennis, say something.
What? I missed something.
No, it's just silent. I think Dennis is going to ask the next question or move the conversation.
Okay. So, is there anybody else, Dennis?
I think Dennis might still be on.
Yeah, it's possible.
There you go.
Sorry about that, guys. Okay, yeah, Dmitro, I just approved you, so please.
Yeah, hi. I got two questions. I'm working on trading application, and our application is running on Windows. So my first question is there any chance for Perf to be intended for Windows? I know you have some kernel modules, and Windows is not open source project.
So I it's been a while since I used Windows, but I get information from time to time from people that say that they are from Microsoft. They say that they're working on having Perf working on WSL. I would take a look at what are the recent information from running Perf in WSL. Like you would, I mean, they would somehow intercept this and get the information that you are asking from the Windows kernel performance monitoring subsystem. I don't know. What I know is that what I got. I don't remember exactly now. I can afterwards try to find this and then tweet about it. Let's say, oh, people asked about Perf on Windows, and that's what I know what's public or whatever. I don't know if Dennis or anybody is making. I'm not making notes now, but I can listen again after I finish this and then try to get the points or extra information. I could provide extra information via some tweet or so.
Okay. Okay, thanks. And the second question is, some time ago I tried to use VTune to profile my application, and actually I failed because my application almost like 98% time it's just listening for market data, and it has some busy loop which just trashes my my CPU, and only 2% or even 1% of the time I concerned about that's the function which actually sends the order. And I tried to profile exactly this this call, and I failed because VTune just collected like 10 gigabytes of data and crashed. And
So
you mentioned that there is a perf probe, right? Is this a tool which I can?
Yeah. So take a look. What you are talking is what I have until today to submit a talk for the next DevConf in Czech Republic, but will happen again virtually, which is ways for you to only consider a set of events after some other event and before some other event. For you to slice and dice, let's say, you collect, let's say, the events that you have interest in, like CPU caches or cache misses or whatever. But you then collect as well extra events that could be trace points or static trace points or dynamic trace points using Perf probe. So you say, oh, when this function happens, I want to know. I want to have a mark. Like, let's say that there will be an event that will be on your Perf data file. And then at the end, when this other event takes place, I also want to be. So I have all the events plus these two. So, and then you can, there are ways in Perf record for you to say, send a signal to Perf record so that it takes a snapshot. So it gets what is in its ring buffer in separate file and continues recording. And then when something else happens, you send another signal, it will dump the contents. And then the files will have a timestamp and etc. That's one way. The other way is that you can say, oh, switch on and switch off events, which is the same thing I described before, but Perf will, and you ask Perf to use a overwritable mode for the ring buffer. So it runs just like a flight recorder. So you say, oh, I want to have a ring buffer of that many megabytes or gigabytes or whatever. It depends on your machine or the amount of memory that you have or the frequency of the events that you are recording. So it goes on like a flight recorder. When it fills up the buffer, the oldest events go on being overwritten. So you have, let's say, the last 2 seconds of events. Well, okay, so that's one thing. Yeah, you have 2 seconds. So, and most of the time you are not interested. You want just to have the last 2 seconds. But when something happens, an extra event that you added via Perf probe, let's say, you say start recording that the events, the cache misses, whatever that I have interest on. And then it starts recording. And then it goes, and then when something else happens, you get out of that spike that you described it. You say switch off the events and then take a snapshot. You see, I mean, there are ways for you to see that only consider the event from one point to another point.
Okay, I see.
So the comment, you take a look at Perf record on the main page, and then there is, I think it's switch on and switch off. And then there is, you will specify what is the name of the event that you want. First, you created Perf probe. You probe, and then you say the name of the kernel. You don't have to say where it is. You just say the name of the function, and then Perf probe say, oh, it specified just the name of the function, so it must be in the kernel. Or you can say -x, and then you say the name of the DSO, let's say glibc, or some specific function library that you have. And then the name of the function, the name, the place in the function, what variables they want to collect, whatever. And then you create this, and then it's an extra event. And then you create the event where the spike finished it, and then you have the two events. Then you create perf record, switch on this one, switch off that other one, and then the events I'm interested in are these. And then it creates everything, and then considers just what's happening from one to the other.
Cool, thanks. And do you think, because it's just one call, one order, and do you think it can I? In case if I send like 5 orders in 10 minutes, I just will have 5 snapshots and.
Yeah. You would have 5 snapshots. Yes, exactly. Mm-hmm. Okay. You send it, and then. But the thing is, the way that this is done right now is that user space creates 2 sets of events, and one is on this ring buffer that's overwritable, and the other one are the control events, the switch on, switch off. And then user space is processing just the control events. So you may have some skew, when you notice the event and you enable the other ones, you miss the start of the action, let's say. And at the end, you're going to get some extra information from the point where the control event happened to the point where you actually disable it. So it has to be, you have to have this in mind. What I'm going to do in the future, and I've been thinking about it, is to do the enabling of the events, not in user space, but in the kernel by using BPF. So you attach a BPF program to that to the probe that defines where it starts. So the time it takes for the probe to fire and the enabled will be shortened. And you can even have extra logic saying, oh, this is the beginning of a spike, but there are other information here that tells me I'm not interested in it. Let's say I'm only wanting spikes that are more than 5 seconds or whatever, or some other 5 microseconds or 5 nanoseconds or whatever. I don't know. You can add extra logic to further narrow down the spikes that you are interested in.
Okay. And I'm also concerned about the data I'm going to get. Will it include all the data from all CPUs or just one core CPU?
No. So the thing is, Perf has this concept of targets. So you can say system-wide, or you can say only this set of CPUs, or you can say just this thread, or you can say this thread and its children, or you can say just on the C group, or you can say only for this C group and it's on the hierarchy below it, or you can say just for this user. Or there are lots of ways for you to, or just for this BPF program, there are lots of ways for you to specify via the Perf syscall what is that you are interested in. Just the CPUs, all the CPUs in some specific CPU socket, whatever. There are many ways for you to narrow it down.
Okay, cool. Thank you very much. That's what is from my side. Thanks.
Yeah, I just wanted to mention Arnaldo's talk from maybe two years ago, which is titled "BPF is eating the world," and this is like, I think a really great example of how you can use BPF program. How you can sample on a custom event that is defined in the BPF program, right, Arnaldo?
Yes. I mean, the BPF is something that came after Perf, let's say, and initially it was not even for let's say for tracing, but then people realized that being able to do aggregation inside the kernel without generating lots of information to user space to then post-process is a really powerful concept. So BPF and tracing nowadays are used, and even profiling is used almost interchangeably. I mean, because lots of people know about BPF because of tracing, because being able to do tracing close to where the event happens and not later on in user space, etc. So combine Perf and BPF. Now there are parts of Perf that are being implemented using BPF. And Perf can profile and count events that happens on a specific BPF program. So when a BPF program is running, Perf will profile just that specific thing, or count events that take place on just that specific BPF. So Perf profiles BPF, and parts of Perf are being implemented in BPF. So it's a really interesting development.
Okay. I still kind of wrapping my head around what you were just saying, but anyway, okay.
Because take a look. There is one example for Perf profiling C groups. The way that Perf works is that you have to create those file descriptors, and where you specify what you want, and then if you have lots of C groups, you would have lots of file descriptor, one per C group. And then in places like Google, and that's where the guy who worked on this works. And another at Facebook, they say, "Oh, I have lots of C groups. If I go on and try to use Perf, I run out of file descriptors." So what they did the following: they created the new kernel Perf software Perf event, which happens when you switch from one C group to the other. You have a context switch from one thread to another thread. Okay, and now you have a C group switch from one C group to another C group, and then they inserted a BPF program called C group switch, and then they create a BPF map, and with one entry per C group. So you have just one Perf events file descriptor connected to this is a BPF program that has a map, an array, just an associative array. And then when you do the context switches, you just bump a counter on that specific entry for that specific C group. And then in the Perf stat user space, there is an abstraction that says, "Oh, this is a BPF event, BPF Perf event," let's say. And then instead of reading it using the Perf syscall, you use the BPF syscall, read the contents of the BPF, and show the Perf stat usual output.
Interesting. Yeah, that's powerful.
Yeah. So I think if we would try to do this in the kernel, like this new Perf functionality, we would have to change the kernel and recompile the kernel and ship it to lots of machines, let's say all of the fleet for Google or Facebook. But nowadays, those fleets, like all the machines in Facebook, all the machines in Google, have BPF already. So if you do it like this, you don't have to replace the kernel. You just send a new BPF program and a Perf tool that knows how to load this BPF, connect it to the right place, and read the aggregation done in the kernel by BPF on BPF maps. And I mean, it's really powerful.
Yep, sounds good. I would love to see some kind of collection of of different techniques which people developed over the years of how they can use BPF to collect interesting data.
Yeah, I mean, there is a book by Brendan Gregg, which is BPF performance tools, and in the in this book, he has lots of BPF programs, lots of small BPF programs, just to show the life of the TCP packets. Or I mean, there are many. There is a BCC, which is BPF file collection. and you have like run queues lower. So it's for you to see what are the threads that are running on your machine that are taking more than n microsecond to be go from ready to run to running. So the delay in the scheduler is having for specific threads. So there are many. I mean, if you look at the book and if you look at the Brandon Gregg BPF performance tools, the book, I'm looking at it right now on my bookshelf. That's what you are looking for.
Okay, yeah, thanks. Yeah, it's on my list. I haven't yet read it, but yeah, probably I should. Okay, thanks. One question from the Discord chat. Any plans to get further levels of top-down besides L1?
Top-down, you mean the Intel? I mean the technique that Andy Kling is I think the biggest supporter. I mean, nowadays, if you run perfstat on a machine that has the top-down counters in hardware, it's the default now. I mean, so the support for top-down is improving. Has improved recently. It's now on the default output for perfstat. Like if you do perfstat something and you are on a machine, on recent Intel machine, you're gonna see the output for the top-down counter. So it's a first-rate citizen, as the Intel people send the patches and processing it, and the community is interested in having it supported as best as possible. So if you have some specific requests, send it to the mailing list. This is Carbon Copy, Andy Clean, and the other guys from Intel, and yeah.
Yeah. So let me also complement your answer. Like, so I think that another issue here is that many hardware vendors simply do not support anything besides L1, right? So for example, ARM only supports like the L1 breakdown, level 1 breakdown. So, and then I'm not sure about AMD. I haven't checked for a while, but I think like at least a year ago they also supported only first level, I guess, of top down. So that's not something that Perf can use across all the architectures. So
yeah, well, one thing that I see recently that is kind of related to this are metrics, yes? Where Ian Rogers, Ian Rogers, and people from ARN, they have. I mean, with Perf you can read counters, and with perfstat, you say, oh, I want to know how many of these events took place when I ran this workload, or for 2 seconds on the specific CPU, or for 2 seconds on the specific PID, or whatever. And then it will set up the events, the counters, and then at the end it will show you. But sometimes counters in isolation are not that interesting. What is interesting is the ratio from one event to another event. Like the simplest one, it's instructions per cycle. But there are others which are way more complicated that like top down, that you have to get 5 or 7 counters and then equation, and then you show the all those meta events, the meta counters. So I would say looking at the Git repository. Looking for metric, Perf metrics, you're going to see lots of examples of what people are doing in terms of getting expressions that are provided by vendors. Say, oh, you have to look at all those events and then do this calculation, show the result. Could go somewhere, but I understand now that the question was about the level 1 cache, and for you to get it, it would require
Oh no, so sorry. Well, I think the question was regarding level 1 top-down metrics is like retiring bad speculation,
Okay.
front-end bound and CPU bound. Yes.
Okay.
Yeah, that's what. Okay. All right. Also, wanted to ask. So since started since we started talking about those hardware specific features. So how this process is is organized? Like many companies are contributing to Perf. Like they try to enable their hardware features. Like AMD, ARM, and Intel. Obviously, all those companies try to enable their hardware features one day. Once those features are coming into the market, right? So how this process is going, and any fun stories you can tell maybe?
So Intel PT, yes. In 2013, I was having vacation with my girlfriend, and I decided to work from there for a while. So I went to visit a friend of mine who worked in the previous company, and I was in Finland. And then he said, "Oh, I'm working at Intel, and come give a talk here to the guys Intel Technology Center in Helsinki. I think I don't remember right now if it Helsinki or was Espoo. I think it was Helsinki. And then there I was the first time I met Adrian Hunter and Alex, the guys who are the maintainers in Perth for Intel processor trace support. So they were. I gave a talk, and then they started saying, "Oh no, there will be this new feature. They described processor trace, and they described what they were doing behind their doors. And I mean, I couldn't even see the source code, but the description of how they were getting the processor trace information and then synthesizing normal perf events so that they could initially just use the tools in perf unmodified, let's say. For perf, it would be looking at branch message, but it was not branch message. It was processor trace information that was messaged by some front end, some library that was perf. And then I think 1 year later, that batch started being submitted, and we had to go through a series of reviewing phases, and it was merged. And then later on, when the ARM guys wanted to have something similar, the core site, which is kind of like Intel PT for ARM, I just tried to connect the Intel behind processor trace so that they could work together with the ARM guys, and then infrastructure that was put in place for the Intel processor trace could be used for the core site, and it was done. So it was really nice, and now we support not just one but two processor trace facilities available in the most common architecture, x86 and ARM. So that was interesting. And more recently, there was lots of patches for Alder Lake, for Intel's Lido architecture, where you have processors that are faster, and there's some processor which is lower but consume less power. And then PerfStat has now, when you run PerfStat, you have to differentiate what is running on one, on the other, and get some sort of output that makes sense. And then there were all sorts of changes in the source code to have support for this hybrid architecture. So there were changes in the kernel, which I was not involved in. And then there were changes to the perf tooling that I processed, and in coordination with the maintainers for the kernel part of perf.
Right. So okay. So let me actually ask about this hybrid. So do you like kind of break by small cores and big cores? Like,
yes.
So do you? Okay. Mm-hmm.
Yeah.
All right. Okay. And then so I also wanted to ask, so that like so as long as like the company provided the, let's say, the enablement for the specific hardware features, you usually accept it, or there are situations when you say like for example, no, that's something like even though the hardware support is there, we just like it ends like, and we don't want to have this.
It's possible. It's possible. I mean, there are cases where, let's say, the simplest ones where people send a patch that it's too big, and we say, oh, we have to break it down into. I mean, we have to break it into smaller. You are doing too much stuff in just one patch, so you have to do it. Or sometimes they get information. Right? They obtain information about the page size or some characteristic of the system using a function, and we say, no, we already have another function for this. You should be using this instead of doing it yourself. You can use this perf environment structure that is available from the perf data file or from the system if it's a live session. And so instead of doing it yourself, you have to use this interface. In other cases, we can say, oh, no, you have to work with this other guy because he's working on the same area for a different purpose, but you have to coordinate. Or I can say, oh, you have to rework this because on my test harness, where I have lots of containers for all the last 5 versions of Fedora, Ubuntu, whatever, lots of things, lots of distributions, and cross-compiling, it fails here because in 32-bit there is a problem that only happens when building for 32-bit, or when happens when using the newer version of GCC, which is like in the Debian experimental, or which is in Fedora Rawhide or Tumbleweed or Clear Linux, and then I just send it back to the person and say, oh, you have to take this into consideration, fix it, send it again. Sometimes not even me, it's somebody else. Somebody else says, no, that has a problem. So it's the normal process of getting patches accepted for the Linux kernel. The perf is developed in the kernel sources. And we try to follow as much as possible all the procedures. The way that the kernel patch is processed is the way that the perf patch is processed. That's it.
Right. Can I ask about your communication with Linus Torvalds, maybe? Even though so I assume that you accumulating like patches from everywhere, and then you send them.
Yeah, in the beginning, when I was invited by Ingo Molnar to work on the because they can Ingo, Thomas, and Peter Zylstra, Thomas Glascher and Peter Zylstra, they came up with the kernel side and said, oh, that's how the kernel has to abstract this performance counters and etc. And that's the way. And then they needed to have sample user space application, so they started creating on the documentation directory of Linux. When perf started being developed in the kernel, there was no user space components in the kernel sources. The kernel had only the source code for drivers, for the scheduler, for memory management, block layer, whatever. There was no user space components in there. It was not like PSD where you have everything on the same revision control system. So was documentation, so I started getting what Peter and Thomas were trying to write, but they don't like to write space components, and so I started working on it, and then I created a Git repository for perf, and then from time to time I send my request to Ingo Molnar. Ingo Molnar processes or say, no, this is not, I don't like this, or I don't like that, or this is stopped working, or wherever. So I fix things, and I process patch from others. I do my work, and I send to Ingo. Ingo processes it, and then sends to Linux. I think that 2 years ago, Ingo was, busy with other stuff, and so it was slow in processing. And I said to him, most of the, like 100%, 99% of the time for at least 3 years, I sent my patches to Ingo, and Ingo just say apply or pull it, and then just send it to Linux. So, he was not doing anything, let's say. He was just getting from me and sending to Linux, getting from me and sending to Linux. So to reduce the load on Ingo, we decided that I would be sending the patches directly to Linux. And it has been just like that. But nowadays, the only communication I get back from Linux is when something breaks or a notification from the dit bot, a robot that says to me, "Oh, Ingo processed your patches and processed the pull request that you sent." So, when everything works, there is no communication.
Right. So I just wonder, if there were like situations when like Linux would just say like, no, I will not accept that. So what do you do then?
No. With Linux, there was not something like that. He only said something. The last communication I got from him was when somebody added something that when you build it without using a build directory, when you build perf in the kernel sources, like the object files are generated in place and not in a separate directory. Linus noticed that he rebuilt perf and did a git status, and then there was this file, and so I had to fix it. And then he said, it's not a problem. There is this new file that appeared on my build, and it's not right for it to be there. So I looked at the problem and I fixed it, and then sent him a pull request that was fixed, and life goes on. He found problems with perf. Several times, and then he commented on the output from perf, annotate, or there were complaints that came from him, and Ingo Molnar always said something like, when he complains about something, you stop what you are doing and you fix the thing, because if he doesn't complain, if Linus doesn't complain or praises what you are doing, you are really valuable. And I say that not just from Linus, but from everybody that takes the time to report problems. And sometimes it falls through the cracks. Yes, sometimes you get a report and you cannot work on it straight away. But as I said in the beginning, I think that the value of perf is in trying to accommodate as much works and user requests as possible.
Yeah, thanks. Travis?
Yeah, hi, Arnaldo. I had a question about the backwards and forwards compatibility of perf. So in two scenarios, can you use a newer or older perf binary against a newer or older kernel? And also about the data file. So if I report a data file with one version of perf, what are the rules for consuming it with a different version?
So the thing is, the intention, the goal, is for you to be able to mix and matches. There are distributions that even package perf as if it is tied to that specific kind of version. But no, we even have a top level kernel source code make target, let's say make perf tar gz, let's say something like that, and then it will generate tarball with just the files needed to build perf, and then you can get this tarball, and from what we have right now on Linus Torvalds Linux Git repository, and then you go to a 4.20 kernel, let's say machine running 4.20. It should work. It should work. Let's define work. If you ask for a feature that the kernel doesn't support, bail out and say, I cannot do that. This kernel doesn't have support for that. if it tries to use a feature by default, let's say precision level, and when you say perf top or perf record, it will try to, in Intel machines, it will try to use the most precise level. That's something related to PEBS on Intel to reduce the skew, and it will try with cycles P, capital P, and if the kernel doesn't support that precision level, that request that you are making, it will try to get a little bit less precise, let's say double P. And if it doesn't support 1P, and if it doesn't support P, even on machines where it cannot use, let's say, cycles, the hardware event, it will try to fall back to something else, like task clock, or trying to get something close to what you are asking for. It has, when you are creating an event in the source code, there are a variable that is perf missing features, let's say. So depending on what you are requesting, it will try to select some features. And then if this feature is not present, it will tell you that, or it will try to fall back to some, in some cases. So in theory, if it should fail graciously, or it should do a fallback to something which is equivalent or close to equivalent. So you could use it, yes. You can use a new perf on an older kernel and the other way around.
Awesome. I always used it like that, but I wasn't sure if it was supported. So I usually use the newest version of perf on like whatever kernel Ubuntu has.
Yes, yes.
So what about the same question, but for perf data files? Is that also supposed to be compatible?
Yes, but I would say that, I don't have this tested to say, it's completely, or is being continuously being tested, this specific thing, like I get the perf data file from a long time and then try to process it now. It should work. If it doesn't work, you should try to report it, and then we can try to at least correct some bug in supporting this mode of operation. But this mode of operation, supposed, we are not saying don't do that. It will not work. We say try it. It should work.
Great. Thanks for your answer, Arnaldo. Dennis, back to you.
Okay.
All right. I think we'll slowly wrapping up. Just maybe like a final question from Felipe. Felipe, hi. Felipe, hi. You can speak now.
Okay. My mic was off. So today we are in a multi-core area, and there is some work for some people that have done. I think it's being right now not so complicated that was in the past. But what they did was they took two workloads, GCC and MATLAB. So they run GCC alone, and they registered the performance. And then they run MATLAB, and they also registered the performance. And then they put MATLAB and GCC to work together. And they found out that MATLAB was playing denial of service to GCC. So because they were running together, one was affecting the performance of other. So the problem of performance isolation. And I think this is a really a problem today, because today now a particular workload, the performance of this particular workload depends of the core workload that is running together, for example. So I want to know if tools like Perf, for example, there is a way for Perf to identify when a particular workload is a potential threat to another one, for example.
Yeah, I mean, you should run perf in system-wide mode. Yes, you are not recording. If you do perf top, let's say you do perf top, and you can specify in perf top what is the aggregation that should be done. And by default, it show you, let's say, the DSO and then the symbol. But you could say that there are lots of ways for you to say that. You could say perf top -s from sort -s and DSO, and then you run your work. You run your MATLAB, let's say, benchmark. And while it's running, you look at perf top and you're going to see cycles are being spent on your machine. And then you will clearly see that there will be MATLAB and something else. And I mean, it could be something else that's running on and that's taking cycles away from your machine. From the work that I do with the real-time group at Red Hat, CPU isolation is the technique that you use for these. You would say something like, oh, GCC should run just this CPU or just this CPU socket. So it will not run on the whole system. And then I will run this MATLAB workload just on this other set of CPUs. Then you isolate. One will not be interfering with the other because you say that this workload is really important, so I'm dedicating a set of CPUs for it. You can do this kind of tricks with using C groups as well, by assigning to some specific C group a set of CPUs. But yes, if you run multiple things on the same machine, they're going to be competing for the same resources. And GCC is really hungry on CPU, yes? Depending on the workload that you are doing, if you do compile the kernel, during the compilation of the kernel, if you use -J, lots of CPUs, everything else in the system will be impacted. And I mean, yeah, you can use perf top to see who is competing for those scarce resource.
Yet the another problem is that this kind of behavior is kind of dynamic. It changes from time to time. And if you take one particular workload and you isolate it completely, like forbidding others to use that resource, and then this another one that actually just not making, after a while, is not using too much that particular core, for example, it becomes a problem of wasting energy because you have work to be done, but you isolate this one, right, to use a particular core, but this one is not using all the resources for this core. But you have work to be done in your system. So it's kind of, like I say, it's need to be balanced. And what people have proposing from some paper is identify dynamically when this event disappears and they start rescheduling out the system again. So dynamically, for example, and not to have a statical scheduling that separate or isolate two programs, but what you have is a dynamic scheduling in the system that keep taking into account how contention is happening, and they start solving it in a dynamic way. So I think this is a way more intelligent approach, I would say. But I don't know how it's being used in industry today. It's just papers that are proposed that is there. Maybe some people are using.
Yeah. I mean, scheduling competing threads, it's a never-ending story. I mean, how you will communicate. I mean, the kernel tries to do this juggling of requests as best as it can. Like, I mean, there are all sorts of algorithms, all sorts of heuristics that it uses, but in the end, it's heuristics. And so somehow you have to tell the kernel what is important, what's not important, how to partition these, establish limits for the use of resources. And C groups nowadays, I think, is the area that you should, anybody with this kind of need should be looking at to use C groups and all the other ways of partitioning the system, the more recent ones, than just having different users and like grouping threads by users and then saying that some daemon is more important than the other. So C groups is the way to go for specifying limits and all kinds of resource utilization. And Perf can profile C groups. You can see what are the C groups that are taking the most of. Even for consumption, you have events in some specific hardware where you can look at how many watts some specific CPU is taking or some specific processes using. So yeah, I mean you can use Perf to understand what's happening in the system, and then you establish those limits, and then you observe again with Perf, and so yeah, now things are running the way I want.
Okay, so thank you. That was my questions.
Okay, so Arnaldo, before we let you go, if you can briefly talk about what are the future Linux Perf, like if there are any teasers that you can make of what's coming in the new versions of Linux Perf.
Yeah, I mean there are lots of areas that have been driven by other people, but in my case, what I think is interesting is the further integration of eBPF and Perf. I mean, Perf should use eBPF to reduce the cost of performance operations that were solved in the past, in the pre-days, by changing the kernel and adding new algorithms and etc. Instead of changing the kernel, we should write more features, but to do more in-kernel aggregation. Even some of the bucketization for Perf top, etc., could be done inside the kernel to reduce the cost, further reduce the cost of Perf data collection. And one thing that I plan to cover in my next talk is about this slicing and dicing, like describing what Perf already does, which is quite a lot. I mean, you could say I'm interested only in the first 2 seconds, or I'm interested only when garbage collection is happening on this specific, system tab has several steps to go from a script to a kernel module. So I want only to know what the second, let's say, the second stage of transforming something into a C program, calling GCC and generating. So you have some. I want to reduce the cost of this by using eBPF to implement a feature where Perf sets up and then specify that an extra event is when the first set of events should be really enabled, and then connect this to the start of those phases, and again to get the promise of eBPF, which is to get processing aggregation closer to where the event happens, reduce the cost of transmitting all this information to user space, while keeping the usual Perf workflow as it is. I mean, people are used to it, so we should improve it by using eBPF. And this is not just me. The man at Google did it for C groups. Song Liu did it for counting events and sharing counters using eBPF. We presented the talk at the last Linux Plumbers conference describing exactly that. If you're interested in this area, the recordings and the slides are available online. But yeah, I think that the looking forward, more and more integration of the fantastic amount of eBPF infrastructure and way of doing things, way of connecting to events, way of processing, aggregating it closer to the events, together with the Perf user space tooling that's transparent to users and provides more ways of transforming the data that's collected into something that's more usually easily digestible.
Okay, yeah. So it looks like certainly BPF is eating the Linux world. Yeah.
Yeah.
So okay, well, Arnaldo, thanks a lot for your time, and I'm sorry we didn't get to the PA hole. We just don't have enough time for it, I think, today.
I think PA hole would be another Twitter Spaces opportunity. There's there are a lot that you can do with that. There are lots to be talked about. There is lots about how PA hole interfaces with even Perf, let's say, for data. Instead of profiling code, profiling data structures. And having an output that's similar, that's the way that PA hole shows information, but showing what are the fields that are most accessed, locality of reference detection. There are lots of things that the interface with BPF, PA hole, and Perf could provide really interesting features.
Cool. Yeah, maybe that's a topic for another discussion. Maybe you can come sometime in the future again. Yeah. So thanks for your time, Arnaldo. I really appreciate it. And I think that from the whole community, let me just say a huge thank you for everything that you do with Linux Perf. We are all fans of this great tool here. So again, thanks a lot.
Thanks a lot for having me. It was a pleasure thinking about this tool.
Thank you. And for everyone in the room, see you in 2 weeks and happy performance tuning.
Bye-bye.
Thank you very much. Thank you. Bye.